So let's look at 11C. It's important that you guys are paying attention to this because these problems have a little bit more going on with them than yesterday's. Most of yesterday's was a single step where we just added to both sides or subtracted. Today's we're going to mainly have 2 steps, if not more. So, like I said, we're going to do some of these together, and then I'm going to let you explore and practice them on your own. So let's look at number 1. Here's my variable, right? X. I need to get it alone. However, there's a 1/5 and a -3 on that side. So I need to get rid of both of those. What do I get rid of first? Great. Jake said the 3, and he's right. So since it said -3, we're going to add 3 to both sides. Make sure you're with us. That left-hand side will be left with 1/5 x because the 3's cancel. And then I have less than or equal to, and make sure we're doing our negatives correctly. -1 plus 3 is 2. Okay, so super important, guys, that you know which one to get rid of first, because sometimes you get rid of the wrong things and your work is great, you're using the right operations, but the wrong order, and then everything is wrong. So please make sure we understand that we would add 3 here first. Okay, now we have to get rid of this 1/5. Who knows how we get rid of 1/5 here? Great. Tim said in class, multiply by 5. And exactly, this is multiplication. So I need to divide, but how do I divide fractions? We multiply by the reciprocal. So you can say 5 or 5/1. Okay, don't forget about reciprocals that we've learned about. So that cancels on the left-hand side, so we're left with x. I'm multiplied by a positive, so my symbol stays as is. And then what do I get on the right-hand side? 2 times 5/1 is 10/1, or simply just 10. So now we'll go ahead and graph. I'll put 10 in the middle, 11 and 12 to the right, and 9 and 8 to the left. Okay, less than or equal to, so we have a closed circle. And to the left or to the right? To the left. Good, Jordan. Any questions? Okay, let's do number 2. Similar type of stuff. Operations may be slightly different. So here's the variable, W. So what am I going to move first? Good. Jake again said, let's move that 8. And exactly, that's least attached. So it's a -8. So how do I undo -8? We add 8 to both sides. Yes. Watch out here, right? That 8 will cancel, but don't forget there's still a negative left in front of that 5/2. So we have -5/2 W is less than 1 plus 8 is 9. Okay, similar to the last problem. How do I get rid of this fraction? I use the, what's the word? What's that vocab word? Reciprocal. Yes, sir. Okay, Jake's on fire in here. Let's hear from some people at home too. Make sure you're engaged. So the reciprocal of -5/2 is -2/5. We flip it. If I do that to the left, we must do it to the right. So multiplying -2/5 on both sides. That left-hand side, by doing that, cancels. So we just have W. Don't forget we multiplied by a negative, so my symbol flips. Lot to remember. And now we actually multiply on that right-hand side. I would encourage you to write 9 as 9/1. Okay, what's going to happen here? What do we get as my numerator? 9 times -2 is -18. And 1 times 5 is 5. Is that a nice, pretty number? No. So we're going to leave it like this, right? I can't actually reduce that or divide it. But my question to you is, how do I graph that then?
Just write -18 over 5 and then 19 over 5.
Sure. So Tim is saying write -18 over 5, -19 over 5, so forth. That is fine. Okay. So I'll do two options here. If I do it that way, we have -18 fifths. What's to the right? -19 or -17? Good. -17, right? When we're negatives, we actually go the other way around. So this is fine to do. Okay, so we'll finish this way. That means an open circle. And again, we flipped that sign to be a greater than since we multiplied by a negative, so we go to the right. If you don't like that, or you may see this on IXL, you may see this on a standardized test, and if it doesn't have an improper fraction, it has a mixed number, how do we figure that out? How do I make improper fractions mixed numbers? This is a skill you should know from middle school. How do I make -18 fifths be a mixed number? Like, is that...
-3 and 4.
How did you get that? So Tim saying -3 and something. How did you get that -3?
Because it's 18 over 5. And 5 goes into 18 3 times.
Exactly. So we're going to divide. How many times does 5 go into that -18, right? So 5 goes into 15 3 times. So we know it goes in -3 times. And if it goes into 15, then the remainder is from 15 to 18 is 3 more. So this is the same thing as saying W is greater than -3 and 3 fifths. So if you wanted to graph on a number line that, and so we'd have -3 and 3 fifths, -3 4 fifths, -4, that type of thing, you could always do that as well. So please understand how to go back and forth between improper and mixed numbers in case you have to graph it that way.
Which way would be?
On a test, like on your worksheets, you can do it just like I did. That's fine. I just want you to know how to do that because there could be a question that, they just, maybe the graph, the number line is already there and they've just plotted -4, -3, -2, that sort of thing. Then you would know your circle would go between -3 and -4. Does that make sense?
Mm-hmm.
Okay. So just make sure you understand how to get impropers to be mixed numbers. All right, let's look at a couple of more together and then I'll have you try some. So let's try, I just want to scroll down to see if there's anything else. Let's scroll to the next page and let's do 5 and 6. So 5 and 6. Sometimes this throws people off on number 5. What's going to be the first thing I move? Tell me the first thing I'm going to move. Let's hear from somebody at home. Let's hear from somebody at home. What should I move? A 4, a 6, a 3? What do we think? Some of you guys used to participate quite often, and I don't hear your voices anymore. It's okay if you're wrong, but let's get engaged.
4.
Good. Exactly. That was you, Gabe, right?
Yep.
Good. So exactly. We're going to move the 4 first. Here's the tricky part, though, that some of you guys always do, and I don't blame you. I understand it's a little tricky. You see a minus sign after the 4, but that minus sign is after the 4. Ignore it. What's the sign with the 4? It's what's in front. If there's not a sign, what does that mean? A positive or a -4? It's a positive 4. So to undo this 4, we're going to subtract it. Don't let the minus sign after the 4 confuse you to think we should be adding. Okay? Now those 4's cancel, and I'm left with negative 6x. Don't drop the negative attached to the 6. And then 3 minus 4 is negative 1. Okay? Now, again, this is where some people were thinking we need to add 6. But we're not adding 6, even though it's a minus, because it says negative 6 times x. So to undo multiplication, we need to, divide. I'm left with x, but I divided by a negative, so flip the symbol. Good. And then on the right-hand side, a negative divided by a negative will give me a positive, and don't trick yourself. This is 1/6, not 6, right? It's not saying 6 divided by 1, it's saying 1 divided by 6. So how do I graph that? Well, 1/6 is between 0 and 1. So I'll have 1/6, I'll have 1/6 here in the middle. And then to the right, I'll have 2/6, 3/6. To the left, I'll have 0 and then negative 1/6. Okay, is everybody okay with number lines with fractions? Remember not to hesitate to just chime in if you're confused. Open circle on 1/6. And again, we flipped that symbol, so it's a less than. So to the left. Any questions? All right, let's do number 6. Because the variable is on the other side this time. So here's my variable. What am I going to get rid of first? We got 3 things, 11, 7, and 3/4. Good, Jake. 7. 11 is already on the side we want it to be, so that's good. 7 is least attached, so we get rid of that first. It's a positive 7, right? The negative goes with the 3/4. So to undo the 7, we subtract 7. 11 minus 7 is 4, our less than symbol. And don't forget, this is saying negative 3/4 m. Okay, this is like one of the earlier problems. How do I get rid of the fraction? Use the reciprocal. Good. And don't forget the sign with it. So the reciprocal is the flip of it. Instead of negative 3/4, it's negative 4/3. And I do that to the other side as well. Don't drop the negative. Really important if you're at home that you are paying attention and copying these things down correctly, okay? On the left-hand side, I'm going to write that 4 as 4/1. And now we just multiply across. Negative 4 times 4 is negative 16. And 3 times 1 is 3. I multiplied by a negative, so I know we got lots of work we're doing and lots of calculations, but don't forget that means we have to flip our symbol. Okay, here's the deal. Don't leave your answer this way. I always want to see that variable on the left-hand side. That's the correct side to put it. So I'm going to rewrite this. I'm going to make that m now over here on the left. Nothing changes. So what was happening? It was pointing to the m, so it's going to still stay pointing to the m. So it looks like I flip-flopped it again, but I didn't. I'm just rewriting it so that that variable is on the left. This will allow you to graph properly. And then I have the negative 16/3. When people leave it, like how I'm going to write with the pink right now, when people leave it like this, half of your graphs are wrong. Half of your graphs go the wrong direction. So that's why I'm saying, please, please, please write it the way I have rewritten it. Then your arrow is going to go in the right direction. Okay, so I'll have negative 16 thirds. Then we would have negative 15 thirds, negative 14 thirds, negative 17 thirds, and negative 18 thirds. Less than or equals to, so close circle. And because it's less than, we can see we're going to the left. If you left it as before, you probably would have gone to the right because it looks like a greater than symbol. But remember, we have to read it with the variable first. Any questions right now? Anybody at home confused and have a question that they want to ask? Okay, let me just scroll down a little bit to see if there's any other types that may be confusing. We'll do one more together with the ones with the denominator. So I'll just do, let's go to number 10. Okay, so everyone flip to number 10. We'll do this one together. And then we'll have pretty much done all the different types there are. Okay, so for number 10, what do I want to get rid of first? Somebody at home tell us, who I haven't heard from. And it's okay if you're wrong, but it means you're participating, so that's a good thing. So for number 10, there's a 1, an 8, and a 22. So what do I want to get rid of first? Someone at home. Hold on. Someone at home. Okay, I'm worried about you guys at home because you're not engaged. And that worries me, right? Because I don't know if you're going to learn anything if we're not actually engaged with this. If you get things wrong, it's still okay because that means you're engaged and you're listening and you'll be able to fix those mistakes. So what we actually want to get rid of here is the negative 22 first. So we get rid of denominators first if possible. So it was saying divide by negative 22. So to undo that, I'm going to multiply by negative 22. There's not a ton of room over here. So just understand that we're multiplying both sides by negative 22. That left-hand side is negative 22 times negative 1. That becomes a positive. I multiplied by a negative, so what happens to my symbol? It flips. And then that right-hand side, those 22s cancel, so I'm just left with the negative 8 plus x. Okay, now we should be comfortable. Somebody at home, tell me what's next at home.
Plus 8.
Good, Alyssa. Add 8, exactly. We had a minus 8, so now we add 8. 22 plus 8 gives me 30. And then just like with the last problem, that variable's on the wrong side. We want to get it to the left. So I'm going to write the x on the left. And then I say, okay, it was pointing to the x, so I'm going to keep it pointing to the x. And then we have our 30. And this one is a nice integer value. So we can go ahead and just plot 30, 31, 32, 29, 28.
So anytime you multiply by a negative, your sign changes.
Yes, someone just in class asked, anytime you multiply it by a negative, your symbol. Is that what you're asking me? Your symbol?
Yes.
Yes, that changes. Or divide by a negative. Multiplying or dividing by a negative will flip that inequality symbol. Okay, and now we have an open circle, and I'm less than, so to the left. Okay. So if I look at number 9, I don't see any negative numbers associated with the x, right? There's a negative on the other side, but there's no negatives on the left-hand side with that x, so I'm not going to really worry about flipping.
So it's only on that side.
Oh, yeah. Well, wherever the variable is. Yeah. Okay. And if we're adding or subtracting, it doesn't matter at all. Any other questions? Anybody at home have any other questions? I think we've done like every type of a scenario that would show up. So please remember the following things. Lunch is about to happen, so this is a good spot to end. Is the following things that you need to remember is, just like we said, multiplying or dividing by a negative, we flip our symbol. If the variable is on the right-hand side, at the very end, we need to move it to the left-hand side. And that's going to be worth a point when I'm grading things. So move it over to the left-hand side, and then that'll help you graph it accurately. In terms of improper fractions, you can leave them improper, or you can make them mixed numbers, like on number 2 that I'm sharing. Your choice, as long as you're plotting them correctly. And then please, please pay attention to the order of which you isolate that variable, of how you're undoing things. Okay, make sure we're moving the correct things first. And if you're still confused on that, speak up. All right, so when we come back from lunch, I'm going to have you guys finish this. We'll check in periodically to check some answers, but you will finish that worksheet. And once it's finished, you'll upload it and then IXL. If you don't finish it during class, then that's part of your homework along with the IXL.